In the previous video, I was giving you the explanation about the resolution of a vector, and I have shown uh, how can you find the horizontal and vertical component fx and fy. Here, this video is the continuation of the previous one, and just to more clear examples. Uh, I'm going to give you a numerical example. I say that again I'm taking the same example that say the 10 Newton force is acting 10 Newton force is acting on a body by making angle theta, and I'm here now giving you the value of the angle theta. Say for example, say the 30 degree. So this force F is acting on this body at 30-degree angle, and the question is here find horizontal and vertical component. So student, this is a sort of a numerical example. The 10 Newton, listen again, the 10 Newton force, a body is hidden over here at the point O, and this is the vector OA is the 10 Newton. The question is the 10 Newton force is acting on this on a body by making angle theta 30 degree. And the question is over here, find the horizontal and vertical component of this force. So uh, keep in mind, first of all, we have to make the data. The data is say fx is we have to find. This is the say question mark, and this is a horizontal component, and this is fy is the vertical component. I'm giving you the revision of the to connect it with the previous video. Uh, this topic is the resolution or breaking of a vector into component, and these components are called rectangular component. The component which is parallel to which is parallel to the x-axis is called fx, and the component which is parallel to the y-axis is called fy. And the formula in the last video we have calculated the drive the formula that fx is equal to f cos theta and fy is equal to f sine theta. So student, remember this formula for test or exam, and this is basically this question is the basically use of the knowledge about the horizontal and vertical component, and how can you make the data has marks in the exam. That's why first of all you have to collect the information by the given condition that is called data. So you can see clearly what is the information given over here in the question, that is said f is given 10 Newton, theta is given 30, fx you have to find, and fy you have to find. So that's why you can say that fx formula for the fx is f sine theta, fx is f cos, formula of the say fx is f cos theta and fy is f sine theta. So I'm going to I'm going to calculate the value for your understanding. This is the fx you are going to find, and f cos theta is the formula. What is f here? You can see in the data, and what is theta you can see in the diagram and data in data, that is basically 30 degree. So student, you have to mention formula first, and then you have to put the value here. F is 10 cos 30. You calculator is allowed in exam or in test, so you can put the value of cos 30 over here. Cos 30 is 8.866. So you can multiply the 10 to the value of the cos 30. Cos 30 is 0.866. So you will see the answer when you multiply mm, 0.866 by 10. So you will get 8.66, and this 8.66, when you round off, that will be 8.7 8.7 Newton. The student, very uh, much clearly you can see that this is basically 8.7 Newton, although it was a uh, 10 Newton, but due to the angle, this I have explained that due to the angle, the horizontal force is basically say uh, reduces and become 8.7 Newton. If this force act at 0 degree angle, so 10 Newton of completely will be uh, towards horizontal direction. But due to the angle, it is now 8.7. Now similarly, you can find Fy. Here Fy, formula of the Fy, recall the formula of the Fy is F sine theta. And again, the same procedure you have to follow, and you have to put the value of say F and theta over here, and you will get 10 and sine 30. Student, you can use calculator, but sine 30 value is half or zero point 0.5. So when you will multiply that by this is sine 30, when you will multiply by 10 to zero point 0.5, so you will get 5. This is a 5 Newton. Uh, Student, you can see clearly that Fy is 5. And this is the example, or very simple, you can say it is the use of the say formula. And now we are going to explain the next topic. Basically, that was the example of the previous video, in which I have explained the resolution of a vector. So now this is the addition of a vector. Vector addition is the operation of adding two or more vectors together into a vector sum. Basically, in this topic, we will learn a lot about the addition of vector, about the joining of vector and resultant vector, and different conditions we will discuss by for the resultant of a vector. And inshallah, here in this video, we will discuss the different types of vector, like position vector, null vector, unit vector, direction vector, and resultant vector. So here in this slide, you can see clearly what do you mean by A plus B. A plus B means that there were two vectors A and B, and when we join them to find the uh, resultant vector, so that is basically A plus B. Uh, Although it is clear in the slide, but to more clear, uh, I'm going to give you some close view and explanation, that suppose that two vectors are here, uh, when you take an example. So this is say one this is say that to raise a vector. This is say, for example, a body is pulled by this body is pulled by say two forces, say 10 Newton and say another force say 5 Newton. 5 Newton and 10 Newton are two forces are acting on this body in the same direction. Okay, so what will happen? The resultant force will be 10 plus 5 because the both vector forces are in the same direction. Therefore, the resultant force will be 10 plus 5. 10 plus 5 is 15 Newton. So very clearly you can see that when the two vectors are in the same direction, we will add them and to find the resultant vector. So if you want to show clearly the vector diagram in vector diagram, so one vector is 10 Newton. This is the one vector 10 Newton. Suppose this is OA, and another vector say another vector say 5 Newton. So the tail of the second vector will come with the head of the first vector. So it is the method of joining which is called head and tail rule. You know the head and tail rule is used to join the vector. The rule says that when we have two or more than two vectors, so we will join by connecting the tail of the second vector with the head of the first vector. You can keep in your mind tail of the second vector with the head of the first vector. So you can get the resultant vector. So here the resultant vector is OB. You can see clearly the resultant vector is OB. So OB, you can see in the diagram that OB is the sum of OA, OA and AB. OA and AB. So student, it is not difficult. You can see in the diagram that OB is the resultant or the net vector, which is the sum of the two vectors. OB is OA and AB. And student, this is one thing more clear over here. If the forces are acting in the same direction, they will act, and the resultant vector will be the linear sum, which is equal to 10. This is the vector 10, this is 10, and this is 15. So this is 5. Total is the 15. So OB is nothing but 15 Newton. Similarly, when the two vectors are acting say opposite to each other, so student, we will subtract them because of their direction. We will subtract them. Okay, and if the vectors are opposite to each other, so we will represent only by sign negative. Positive, if the positive means the addition, then negative, if the positive means forward, then negative means reverse. If the positive means uh, east, then negative means west. Okay, so here vector we will use the sign only to say represent the direction. So here these two vectors are, you can see clearly, and we have drawn over here B parallel to this and A parallel to this. So when we will add them, so you can see the two ways clearly. Student, you can see the two ways clearly. Basically, say over here, uh, my cursor. This is there are two ways to go, B A or A B. So there were two vectors A and B and two vectors B and A we draw parallel to this. Vectors are the free vectors and we can draw parallel to each other. So where you can see clearly that this A and this has same direction, same magnitude. And this B and this B same direction and same magnitude. Therefore, if you follow the head and tail rule, so go from here, you have two ways to go to reach here finally. For example, B plus A, you are reaching here. Similarly, A and B, you are reaching here. It means the A plus B, one result here is this is the resultant vector A plus B when you see from here to here, or when you see from here to here, it is B plus A. You can write B plus A also, either A plus B or B plus A. So this is the joining of vector or addition of vector. Basically, it is addition of vector, but we use joining of two vectors and we follow the rules that is called head and tail rule. In this slide, you can see clearly that position vector, types of vector, position vector, free vector. Position vector, every vector shows the position. So that is x um, xi plus yj plus zk is the position vector in 3 dimension. Similarly, that free vector, because you have seen in here in this example. See this example where by the color, by using different color, it is clear that we make a parallelogram to add B and A. This is the B and A. So when we join them, we will get A, B plus A. Similarly, we draw another vector parallel to this A, A. These are two parallel vectors which have same magnitude and same direction. We can draw third vector parallel to this, fourth vector parallel to this. It means that this is the free vector. Every position vector is a free vector and we can draw parallel to that vector equal in magnitude and same directions. Similarly, here you can see the red color vector which is B and this is also B. So we are this vector is parallel to this vector. So we can draw the third vector even over here. We can draw the third vector over here. So every vector we can draw parallel to each other. So this is we use in joining the two vectors very clearly. Uh, there were A and B two vector and we want to get the sum by adding them. So we draw another two vector A and B and I uh, it become a parallelogram. Parallelogram. So parallelogram. It's called parallelogram method of addition. There are different methods we can use for addition of vector. Addition of vector by rectangular component method. We will discuss in the next video. And this is the parallel addition of vector by parallelogram method. So here when we use two vectors, when we have given two vector and we want to find their sum, so we can use the parallelogram method of addition over here. So student, you can see clear B plus A or A plus B. So this is also called the commutative property and inshallah we will discuss in the next video about the properties of vector, commutative property, associative property and distributive property over addition and multiplication. So that will be discussed in these separate videos. Here you can see that the position vector, free vector, you can draw vector parallel to each other in the same direction, same magnitude. The unit vector and the direction vector. These are interlinked with each other. The direction vector is a unit vector. You know that vector has magnitude and direction. Therefore, the when we will write, we will do in the next video, inshallah, how can we calculate a unit vector or a direction vector, or how can you show the direction vector is a unit vector. But the definition of the unit vector is when we take the magnitude, when we determine the magnitude of a vector, and if it is 1, so that vector is called unit vector. You can say in easy words, the magnitude of a vector is unit 1. That vector, if the magnitude of a vector is 1, that vector is called unit vector. If the magnitude of a vector is 0, that is called null vector. Every direction vector is a unit vector. It means that when you have given a direction vector, or if you are finding direction vector, you can check your answer is correct or not. The magnitude always be 1. And number 6 is a resultant vector. You have seen over here the resultant vector is either a plus b or b plus a. So the definition of the resultant vector you can see in this diagram, and you can learn easily that it's a vector which obtained by joining initial to final. See here, initial green. See the green vector, initial to final. Okay, this arrow will not be over on left side; it is on right side because that it directed from the initial to final. So one definition is very clear that a vector which obtained by joining initial to final. Or second definition you can say it's a vector sum of all. Means what? Vector A plus vector B is equal to vector R. You can write vector R is equal to vector A plus vector B or vector B plus vector A. So one second definition is that the resultant vector is the sum of all vectors. Is the sum of all vectors, or a vector which obtained by joining initial to final. So hope you understand the different types of vector. You understand position vector. Every vector is called the position vector. Xi plus yj plus zk is a position vector which shows the position in x y z direction. Every vector is a free vector. We can draw a vector parallel to each other, the same magnitude and same direction. And unit vector, that a vector has magnitude 1 is called unit vector. And the direction vector, every direction vector is a unit vector. That if the magnitude of a vector is 0, null vector, and a resultant vector, I have explained. One vector is not mentioned over here, negative of a vector. So that is the vector equal in magnitude in opposite in direction. That is called the negative vector. When you add two vectors, if answer is 0, it means that the both vectors are negative to each other. Hope you understand this contents is the about the addition of vector or joining of vector. Inshallah, in the next video, we'll discuss the addition of vector by rectangular component method.